Our learning target in this video is to be able to calculate the slope of a line on a graph. So I want us to first talk about slope and what it is. So when we're referring to the slope of a line, we're actually referring to the steepness of a line. So just by glancing at these lines that I see here on the coordinate plane, I can right away tell that line B, the red line, is actually steeper than line A, the blue line, because it has a greater slope. And the way that we're going to write slope is a ratio of the change in the vertical distance over the change in the horizontal distance. When you look at this ratio here, you see these little triangle symbols, which actually means delta or change. So change in vertical over change in horizontal. Another way to write it would be the rise over the run. So both the red and the blue lines, line A and line B, have a positive slope. I'm going to draw a quick sketch of what it looks like when you have a line with a positive slope, which both of those lines do. So if I am just drawing a quick sketch of any sort of a line that has a positive slope, this is my coordinate plane. It's a line that's going to start in the bottom left corner and go upward to the top right corner. That would be an example of a line with a positive slope. Oops. A negative slope is a line that's going to start in the top left corner and go down towards the bottom right corner. So this line here would be an example of a line with a negative slope. So when I'm looking at my graph here, I can see that line A, which is blue, and line B, which is red, they both have a positive slope, while the green line, line C, has a negative slope. So now let's actually calculate the slopes of these two lines. So when I'm looking at line A, remember on the previous slide we talked about how it is a vertical change or a change in the vertical distance as the numerator of the fraction or the ratio, and the change in the horizontal distance in the denominator or the bottom part of the ratio. So when I look at the graph of line A, the numerator of the slope is going to be the vertical change. So I'm going to pick 2 points that are on the line, and I'm specifically going to pick 2 points that are on the corners of the grids. So I'm going to pick this point here because it's nicely on a corner, and then I'm going to pick the origin as my other point. So if I want to calculate the slope of line A using this point here, the origin, I'm going to count how far up do I need to go to become even with that other point. So if I go from here to here, I just went up 2 units. So that means the numerator of my slope is a positive 2. Now when I'm trying to calculate the horizontal distance, I'm going to go from here all the way over to here to see how many units that would be. And that's 1, 2, 3, 4. So that means the denominator is 4. So my slope is 2/4 or 1/2. Line B looks much steeper. So I'm predicting that the slope is actually going to be a number that's greater than 1/2. So let's test it out to see if that is actually true. So again, when you're using a graph and finding the slope, you want to pick 2 points that are on the grid. So I'm going to pick this point again on the origin because it's also on the red line. And then I'm going to pick this point here because it's on the corner. So vertical change is the numerator. So to go from this point to this point, I need to go up 1, 2 units. So the numerator is 2. The horizontal change is going to be to the right 1 unit. So the denominator would be a 1. So the slope of line B is 2/1, or I could also just write it as 2. So my prediction was correct in that line B had a greater slope than line A because 2 is definitely greater than 1/2. Now let's look at the slope of line C, which we talked about earlier, has a negative slope. So once again, I need to pick points on the line that are on the graph, and specifically points that are on corners. So I'm going to pick this point here, and I'm going to, again, why not pick the origin for all 3 points? Because all 3 lines, because all 3 lines go through the origin. So remember, to find the slope, it's rise over run, or the change in the vertical distance in the numerator over the change in the horizontal distance in the denominator. So when I'm calculating the slope of this green line, I'm going to start with vertical change. This time, if I start at this point and I go to this point, I'm going to count down 2 units. Because I'm counting down instead of up, it's going to be a -2 is the numerator of the slope. And then to go from here to here, I'm going to go to the right 1. So that would be a +1. So my slope would be -2 over 1, or just -2. So this one has a negative slope, which I already knew because the graph is starting in the top left corner and going down towards the bottom right corner of the graph. So that would be a negative slope.